All right, so what you're looking at here, obviously semester test is Tuesday, January 5th. This practice guide is due on the 4th of January, that's Monday, that's the day before. If you need to study it for one more night, you're gonna have to make a copy or take pictures of it. This thing is due Monday. Now, we will have this all completed by Wednesday next week. So if you're looking up here, we did 3 problems yesterday. We're doing 2 problems today. We have 3 problems on Monday, 2 problems on Tuesday, and 1 problem on Wednesday. That's the one that will take us the longest. That's one you might have to finish on your own. Now, the units covered. Obviously, we had the library of functions as chapter 1. We had slope and graphs on chapter 1. It was the second part of chapter 1. Then we did differential quotient. Then we did the derivatives in chapter 3, which is what we're in now. Now, all the Google Classroom, JMC lessons, all that stuff was updated a couple days ago. But for you guys, if you have something missing still, or you need to make corrections, because I think we had a homework assignment due last night, make sure everything's turned in by Wednesday next week. Okay, so make sure of that, because I want everything done and complete and all that good stuff. So, yeah. So let's move on. Let's get right to our problems today. What? No, keep sliding down and keep talking. So, all right. Anyway, it's new, and I'm trying to get used to a new one. All right. So, what we're looking at here. On the website, if you go to the daily lessons at the top, or if you scroll all the way down, right, the daily lessons at the top, the idea is that down here I have all the videos, all the reviews. They're going to be right here. This is part 1. Part 2.
That doesn't work. I was on there for a half hour last night trying to get it to work. I don't know why you did this. But
These are words of war.
It's right there. I don't know. What time did you check it? I wasn't even home till 7.
Well, after you texted me that it was on.
No, I said I was going to put it on later.
You guys text each other?
Oh, see, I'm not good at that.
You.
Yeah.
I
I said, hey, I haven't got to the video because I haven't got home yet. I'll post it later. Yeah, I think I got home about 8, so I was still posting.
Okay.
So.
Well, the picture, it looked like that.
Yeah, I just didn't have the video uploaded until about 8 because I had this updated after school. I just hadn't put the video in yet.
Oh.
So. Because I had to process it and get through it all. So, all right. Now, here's the idea. So the second part will be right here. All 5 will be sitting here over break. There's going to be no scroll wheel. It'll just be all 5. Click whatever one you need. If you misplace your practice guide, remember you can always print off a new one. It will just be, you have to go to your email. You can either print it if you have access to a printer. If you're not, just put it on a separate sheet of paper and that's what it'll turn in for your practice guide. So, but you have to have it completed. It's worth a lot of points. Make sure it's done.
More points than our test?
What?
I heard pre-calc is 60 points.
This is almost 65 or 67.
More points
Yeah.
than
It's worth
our
it.
test?
What?
More points than our test?
Yeah, this thing is.
But
What?
weighted differently?
Yes. It's worth a lot.
But still.
This is a huge help, I think. Okay, all right. Okay, all right. Hey, let's walk through what are we on? 4th question today? All right, so number 1, we did this one yesterday. I put the graph on here so I didn't have to pull up a graph from the other day. We graphed this one. You have to just graph the parallel and the perpendicular line. You don't have to graph the original. Okay? All right, number 2 and 3, these are the ones we did with logarithms. This one, you have to have a calculator, or if you borrow one of mine, you have to know how to use it. I will not answer those questions on test day. That's why yesterday we spent some time to how to type it in and all that good stuff.
Using the precision tools of mathematics?
Yes,
Yes.
the precision tools of mathematics. I had to quote what the standard was. So now, number 4.
You should just
Like
not
this yesterday.
everything.
A lot.
Weird stuff. It was a weird catching up day.
I
Yeah.
love weird days.
All right, anyway, number 4. We have to graph this thing. This thing has a horizontal shift. It has a vertical shift. It has a lot of different things. So I'm going to just kind of move this. I'm going to rearrange this problem just so you can see what we're looking at here. All right, so this is the same problem. I'm just writing it a little bit differently just to show you kind of what we're looking at here. I just rearranged this thing. So why I'm writing it like this, it kind of shows me how this thing's been shifted. This plus 8 in the back has been a shift up.
Oh, boom, got it.
Because it's a plus 8. This -4 is a amplitude, and it will flip my sign over. So the sine graph usually looks kind of like an S shape where it goes up first. Now we're going to go down first. So it's flipping the graph upside down. So, and then this part is the whole shifting right and left. So it is a shift, but it is horizontal, like left or right. In this particular case, we're going left. Okay. Now, I do not need to know where 0 is, like the origin or anything like that. I basically just need to see the 4 marks and kind of where they're at and where they start. So there's a little bit of things you can do here to cheat this problem, so it makes it faster and easier for you.
What's
So
the amp name?
amp is how tall the waves are.
Oh.
So,
okay.
yeah. So we're going to go through that here in a second. Now, before I begin, this is the part that I always do off to the side to figure out where the starting marker is and to figure out, how far, each marker is away from that starting marker. So let's do the spacing first. So I'm going to put these in different colors. Now, I might have to go to the next slide and just have a blank slide and we'll finish out this problem. So the spacing here. The spacing, how you do this. Normal sine and cosine goes out to 2 pi, right? That's usually what we go out to, right? But in my case, I have to divide by this number that's in front of x. So I'm dividing by 2. So this, yeah, you're absolutely right. This is pi if I simplify it, right? You could leave it 2 pi over 2. I just don't. I just simplify it. Now, why we're doing this is because I really need to figure out the first marker. So I cut this in half to get to this marker, right? That's half of it. That's half the distance. And then cut it in half again. This right here is the most important marker that I actually needed. It is the spacing between all the markers. So to get from the first marker to here, I go 1/4 of a pi. Then I go 1/4 of a pi. Then I go 1/4 of a pi. Then I go 1/4 of a pi. And it gets me to the end. This is the spacing number that I needed. How I found it is I knew what the normal spacing is and divide by the number in front of x. Now, I'm going to use that spacing in conjunction with the starting point. And that's the next piece I'm going to start with. Okay? So the starting point. That's where you take the entire parenthesis, this monster, and I set it equal to 0. And I figure out where did I start. So when I solve this, I don't really need the parenthesis, but I just solve for x, and that just tells me where my starting point is. Was there a question?
He growled. I didn't know if it was
So starting point would be
Negative
pi over 2?
Yes. So when we actually solve this thing out, we subtract the pi over, so it's negative pi, and then we're going to divide by 2, right? Because you have to go in order. You have to abstract first, and then divide by 2. So my starting point ends up being x is equal to negative pi over 2. Because again, I had to divide by this 2 over. That's how I found it. I'm going to go to the next slide here in a minute.
Last pile 4.
Yep. So I'll go to the next slide here in a second, just so we can kind of see what I'm talking about here. Okay. All right. Do we understand that the spacing, and do we understand my starting point?
Yep.
You'll do that on every problem. The only thing that would be different is if the spacing, like if I didn't go out to 2 pi, right? Sine, cosine, cosecant, secant, they all go out to 2 pi's. Tangent and cotangent have a distance of 1 pi, not 2 pi. So that's the only difference with tangent and cotangent. I would, if I'm a betting person, I'd bet sine or cosine here. Just saying. Sine or cosine.
What's the
Prepare for
over?
tangent and cotangent. Prepare for tangent and cotangent. Prepare for tangent and cotangent.
Prepare for nothing. There's no test.
No, stop. We're having a test. All right.
Oh.
All right.
It
It was worth a shot, bro.
Is that a joke?
No.
Yesterday
So-
you told them we're not having tests, and now you're not telling me, so I freaked
Oh,
out.
that would be super evil. No, we're having a test. So,
No, that would be super amazing.
yeah, no. All right. No. All right. So, again, this is my
He's gonna
starting
tell us.
point.
The day we come in, he's gonna say, no test.
No.
Guys, don't study. It's a joke.
Starting point
Don't worry.
and my actual spacing was the 1/4, or was pi over 4, I should say, not 1/4, but pi over 4. All right, now, now on your problem, this is, again, I'm going back to the original problem that I kind of had written up there. Here it is. I don't really care what's in that parenthesis, and we had the 8. All right, so now, here's the idea. I'm shifting my graph up 8, so this marker is at 8. So if I went 4 above it, and 4 below it, that's how I get my amplitude. Again, how I know that is because it's been shifted up 8. So it's up 8, so that means I'm going to hit 12 up here and what, 4 down here for the lowest point. And then I'm going to have 4 markers going across.
And they are negative pi over 4, 0.
Okay,
pi over
so
4.
yeah, so hold on, we'll get to there here in a second. So, all right, is there any questions with how I set this up so far? I'll put those 4 markers in here in a second. I probably should have gave more space just because they're kind of going to be ugly.
I know who's behind me.
All right, are we good?
Yes.
All right. I gotta make sure I'm not muted. Hold on.
Oh, Jake ain't been on.
I feel like they would have told you by
That
now.
would have been really awkward.
I'm just.
Hi, Jake.
Morgan on?
Yes.
If you're muted, you're kind of forced not to give us the test.
No, I'm not.
I would say.
It was actually coming through the
If
projector.
you're not muted, you're kind of forced not to give us the test.
All right, stop. All right, so here we go. This first marker right here, this is considered my first marker. That was the negative pi over 2. That was my starting point. All right, that's where my graph's going to start. Now, to get to the next marker, that's where I have to use the spacing. So I'm going to take this negative pi over 2 and add pi over 4. You do not need to add it. You don't need to actually like simplify that. Just write it like that. The next marker, same thing. You're just going to add 2 of them. Because I added another pi over 4. Then to get to the third marker, you added a third pi over 4. And then get to the fourth marker down the road. I added a fourth pi over 4. And that's how I get to each marker. I do not need to simplify those fractions. I can just leave them like that where usually I would, if I was doing this in my paper, I'd have this really spread so those are really far apart. Just so I can see that fraction really clear. Sorry, I kind of squished them together. Sorry.
Lauren, are we gonna have enough time for this story?
Hey, wait. We're on good pace. This is one that takes the longest, I think.
So then we gotta draw a line.
Then we got to draw our sign. Now, the sign graph on this particular problem is going to go down first, not up. The reason why it's going down is because of the negative sign out front. So we're just doing the opposite of what sign would do. So we're going to go down first, come back to 0, and then go up and back to 0. And there's your graph. That's it. I don't care where 0 is. I don't care where any of that is. This is just what we have. In fact, 0 is actually the middle of the graph, just to let you know.
Next.
All right.
Gonna make you hot.
We're good?
I think so.
Okay, moving on. Okay. Again, I'll have all these pictures in the video on the website tonight. I'll do it. All right, this one that it shouldn't be that long. The last round, I thought the sign graph takes way longer than this one. Out of these 2 problems, the sign, that last one we did was way harder than this one. You just have to figure out end behavior, figure out where the symmetry is, the intercepts, the x-intercepts, the y-intercepts, the horizontal and vertical asymptotes. There's just little pieces. Now, I did not put these in order of how I do them. I just put all the items up here that you need to be able to handle. Okay, so here's how it works. For x-intercepts, you have to factor the top. So if I factor the top of this fraction, this will give me all the x-intercepts. So if I factor that, that's what, x plus 4, x plus 1? So where are my x-intercepts at?
-4.
Yep, -4 and -1. Those are my x-intercepts. And yes, I do want you to list those out up above so I can clearly see it, and then I can see it on your graph too. Because sometimes the graph gets a little messy, so it's nice to see it up above so I can confirm it. Okay, y-intercept. This is where you have to plug 0 into everything. So for the y-intercept, because I know I'm going a little out of order, but I'm going to factor that bottom part. But what I'm going to do is I'm just going to plug in zeros into everything.
4 or -4, right? So -1.
So yeah, so it should be -1. So you're absolutely right. So it should be 0 plus 4 on the top, and 0 minus 4 on the bottom, and you're absolutely right. This ends up being a -1. So that's where it's going to hit on the y-axis. So -1. Again, I plug zeros into everything. Now, ignore that spot where I factor the bottom. Sorry, I just did that real quick so we can get to it on the next part. So again, this, I'm going to put these little notes to yourself. We factored the top for the x-intercepts, and for the y-intercepts, we plug 0 in. Okay,
For
if that makes any sense to you.
vertical aspect.
Okay, are we good so far? All right, vertical asymptote, that's why I factored the bottom. So for vertical, I factor the denominator, which is the bottom. Okay, so when we factor the bottom, what are my two numbers on the bottom? 2 and negative 2. All right, so 2 and negative 2 is how I factored the bottom. So 2 and negative 2.
Where are you writing there? Oh.
Yeah, and maybe I'll make that a little bit easier to see. Not the greatest. Probably for those online, they can probably see it better than you guys can. This green doesn't show up too well on this marker board. Let's zoom in. There you go. All right. So those are the lines up and down at 2 and negative 2. Sorry if you can't see them. Sorry. All right. Now for horizontal, this is where you have to check the greatest powers. So on my problem, I'm looking at the greatest powers here and here. This is how that's how you do horizontal. So we're checking the powers. Okay, so the exponents. If the exponents are the exact same number on top and bottom, do you agree that mine are the same?
Yes.
Yeah.
You divide the leading number out front.
1.
1. So there will be a horizontal at 1. If the bottom number is larger, that's where you'll have to put one at 0. So the bottom is too big.
That's if the bottom is bigger.
Yeah.
So bigger by 1 or more than 1?
Anything.
And
1 or larger.
the top is,
Repeat that for
what was
the
one
boys.
that's like
If the top is bigger by 1, you have to do the slant, and I probably won't put one of those on there. So you have to do a slant if the
You
top is
always
bigger
say
than by
that.
1. I know.
So what if the top is bigger by like a lot?
Then you don't have a horizontal. Yeah. If the top is bigger than the bottom, you don't have a horizontal.
Just by 1, right?
No, it's anything. If the top is bigger than the bottom by more than 1, then yeah, you don't have anything. If it's larger by 1, then you have to do the slant where you have to long divide.
Oh, okay.
Yeah, that's why I have to long divide. We probably won't have one of those on the test.
Same powers, just 1. Bottom is bigger than.
Yeah, and it's not just because the powers are bigger, or the powers are the same, it's 1. It's because the leading number is divided to make 1. Like x squared and x squared, it was 1 and a 1 in front.
So it could be like a 3x squared.
Yeah, so if this was like a 3x squared out front, it'd be 3. Because it's 3 over 1.
Okay.
So,
So wait, the top is bigger than 1, so more than 1, there's none.
none.
Okay, and then if it's the same, you just divide.
Yep. And if the bottom's bigger, it's 0.
bottom's bigger than the exponent, or?
Yeah, exponent. Yeah, I don't care about the numbers, just the
But you
exponent.
said if the top's bigger by 1, we have to slant, but that's probably not going to be.
That's not going to be on the test. I'm not going to put a long division problem on there because it takes too long to do those.
Okay.
Because you have to long
If the top's
divide.
bigger by 1, you divide it for the slant.
Yeah. And it would actually give you the equation like in slope intercept
You
from y
said
equals
not
x.
to do that.
I probably won't do that. No, I can't. It just, we don't have enough time. I would expect a problem like
You
this.
promise me.
So,
He says that, but then he doesn't.
Don't start.
I
You
think-
promise.
I know what the problem is. I already made it. So, all right.
God.
Already made the test.
All right.
Probably not gonna
Okay, are we ready to go?
No witness.
All right. Okay, all right, for the next part, now we have to start drawing this thing. So this is the part, this is probably the most challenging part. The symmetry aspect of this thing is already out the window because the x-intercepts aren't the same on both the right and left side. So I can already throw that out. What I'm putting together here is just an idea. This is where this can be a little tricky because I'm going off of just kind of instinct by where my dots are. So you could have a slightly different looking picture because I don't want to graph this thing on a graphing calculator because not everyone has one. I just want to see kind of roughly what it should do if I went off of these dots. So if I went off of these, this is probably what my graph's doing. Now I'm going to put this in black so hopefully you guys can all see this. This graph over here probably does something like this.
Should I say?
Because
Which one can it not cross, the blue or the green?
it can't cross a green.
Okay.
So you'll see this in the next part. I'm going to cross the blue here in a second. The middle probably is doing something like this.
Yup. Mm-hmm. I like it.
Probably. I mean, maybe it went down. I don't know. I'm thinking like usually they kind of keep the opposite ends kind of going the other directions. And then on the right side, it's probably doing something like this. Just because I didn't have an x-intercept, so it's probably not hitting the x-axis over on that side. So that's how I'm kind of figuring what this thing looks like.
And we're done.
And we're done.
Story time, you gotta tell me.
Who's playing chess?
How in the world did you get those pieces
All
back?
right. I'm going to stop and start the
We
timer.
gotta finish our game.
Keep going.
All right, you guys good at home?
I don't remember. So,
Yeah. All right, thanks for tuning in, guys. I will see you guys on Monday, same time.
Ready for your ride?
yeah, I didn't know.
Work. Bye, guys. Hopefully you're feeling good.
I got next.